Welcome to Well Explained. Students, today I am here with class 10th, chapter Electricity, and the subtopic is combination of resistances or resistors. In the previous topics, classes, we have studied that current in a circuit depends on the potential difference. The current in a circuit depends on potential difference. But there is one more thing on which the current in a circuit depends. That is the resistance of the circuit. So in the electrical circuits of radio, television and other similar things, it is usually necessary to combine two or more resistances to get the required current in the circuit. As you all know, the current which is supplied to our home is same, but the different appliances at our home, they are in need of different amount of current to flow through them. So this arrangement is made by the combination of two or more resistances. Okay. Now we can combine these resistances in two ways. They are in series and in parallel. If we want to increase the total resistance, then the individual resistances are connected in series, and if we want to decrease the total resistance in a circuit, then in the individual resistances are connected in parallel. You can say that if we have to increase the total resistance, we connect them in series. That is, when we are connecting them in series, that is, we are actually increasing their length, and we know that one of the factors on which the resistance depends is the length of the conductor. When we increase the length of the conductor, then the resistance also increases. They are directly proportional to the length is directly proportional to the resistance. And if we want to decrease the total resistance, the individual resistance are connected in parallel. Means when we are connecting in parallel, it is actually we are increasing the area of cross section, and we know that resistance is inversely proportional to the area of cross sections. Now resistance is in series. When two or more resistances are connected in end to end consecutively, that means एक के बाद एक अगर वो connected हैं, they are said to be connected in series. As in this figure, you can see that two resistances R1 and R2, they are connected in series. Now, when the resistances are connected in series, we have to calculate the resultant resistance. So we use the formula, that is there is one law by which we can calculate the combined resistance, and this is known as the law of combination of resistance in series. And according to this law, the combined resistance of any number of resistance connected in series is equal to the sum of the individual resistances. For example, if a number of resistances R1, R2 and R3 and so on, any number of resistance can be connected. And if they are connected in series, then their combined resistance is given by this R is the total resistance or combined resistance, and R1 plus R2 plus R3 plus so on, they are the individual resistances. For example, if we have to combine a resistance of 2 ohm and 4 ohm in series, okay, if we are connecting them in series, the resultant resistance of this will be equal to R is equal to R1 plus R2, R is equal to 2 plus 4 is equal to 6, and it is equal to 6 ohms. Clear to all of you? Now resistance in series, whenever the equivalent resistance is equal to the sum of the individual resistance, and it is always greater than any individual resistance. As in the previous example you saw, two resistors were connected in series. One was having 2 ohms and the second was 4 ohms. We got the combined resistance as 6 ohms, which is greater than the two individual resistances of 2 and 4 ohms. Now series combination of resistances. If R1, R2, R3 are connected in series, okay, if R1, R2, R3 are connected in series, then R equivalent means the resultant resistance or the total resistance is equal to R1 plus R2 plus R3 and so on. Now now we will derive the formula for the resultant resistance of a number of resistors which are connected in series. But before deriving this formula, we should keep these two things in mind. What are these two things? Number one, when a number of resistances are connected in series, they are joined to the terminals of a battery. Then each resistance has a different potential difference across its ends, which depends on the value of resistance. But the potential difference across the end of all the resistances in series is equal to the voltage of the battery. If we see this example which I have given, so the potential difference across this resistance and across this resistance will be different, but the total potential difference will be equal to the potential difference of the battery, which is equal to the voltage of the battery. Number two, when a number of resistances are connected in series, then the same current flows through each resistance. Means the current in the circuit will be same in each and every resistance, but what will be different? The potential difference will be different. So this current flowing through each resistance is equal to the current flowing in the circuit. Okay. Now in this figure, now we are calculating the formula. In this figure, if you can see, so there are three resistances in series. These are R1, R2 and R3. Okay. A battery of V volts has been applied to the ends of this series arrangement. The battery of V voltage is applied. Okay, here the battery is applied. Now suppose the potential difference across the resistance R1 is V1. So, across this, because V said key potential difference is different, so here it is V1, across R2 is V2 and across R3 is V3. Since we have applied a battery voltage V, so the potential difference across three resistors will be equal to the voltage of battery, that is V is equal to V1 plus V2 plus V3. Okay. Now suppose the total resistance of the combination is R and the current flowing through the circuit is I. Then by applying Ohm's law to the whole circuit, we get V upon I is equal to R or V is equal to IR. Okay. Since the same current is flowing through the three resistors connected in series, so by applying Ohm's law to them separately, if we apply Ohm's law to each one of these resistances, V1 becomes I into R1. Okay, this is the equation 3. V2 is equal to I into R2. This is the equation 4. And V3 is equal to I into R3. This is the equation 5. Clear? Now, substituting the values of V, V1, V2 and V3 in the equation 1, we will get, in the starting we said V is equal to V1 plus V2 plus V3. Okay. So, in place of V, we have written I into R. In place of V1, we have written I into R1. V2 is equal to I into R2 and V3 is equal to I into R3. So I into R, we have taken I common, I in the bracket R1 plus R2 plus R3, cancelling I from both the sides because this I can be cancelled with this. We will get R is equal to R1 plus R2 plus R3. In the same way, we can calculate the resistance of resultant resistance of any number of resistors or resistances connected in series. Now coming to the resistances in parallel. Now what are resistances in parallel? when two or more resistances are connected between the same 2 points. Okay, if the two or more resistors are connected, as you can see in this figure, there are 2 points are A and B, and two resistances connected are R1 and R2, and they are between the same 2 points, then we say they are said to be connected in parallel, as you can see in this figure. Okay. Now, parallel combination of resistors. Current through each resistor need not to be same. That means when the resistances are connected in parallel, the current through the resistance is different, and the potential difference between the terminals of each resistors may be same. Means the potential difference across each resistance is the same. Suppose R1, R2, R3. They are the three resistances which are connected in parallel. Now the reciprocal of the equivalent resistance. This is the law of combination of resistors in parallel. The resultant resistance is calculated by applying the law of combination of resistances in parallel, and according to this, the reciprocal of the equivalent resistance, it is the reciprocal, you can see 1 upon R equivalent is equal to the sum of the reciprocal of their individual resistances, and the equivalent resistance is always less than any individual resistances. As we have studied earlier also, if whenever we have to increase the resistance in a circuit, we combine them in or we connect them in series, and if we have to decrease the resistance in a circuit, we have to combine them in parallel. Suppose that there is one example. Suppose that a resistance R1 of 6 ohms and R2 of 12 ohms are connected in parallel. Then their resultant resistance will be given by the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2. That is 1 upon 6 plus 1 upon 12 is equal to 2 plus 1 upon 12 is equal to 3 upon 12. After cancelling, it will become 1 upon 4. That is 1 upon R is equal to 1 upon 4, and R is equal to 4 ohms. And you can see 4 is less than 6 as well as it is less than 12. That means when connected in parallel, the resistance of the circuit is decreased. Now, before deriving the formula for the resultant resistance of resistances connected in parallel, we must keep in mind that when a number of resistances are connected in parallel, then the potential difference across each resistance is same, which is equal to the voltage of the battery applied. And when a number of resistances connected in parallel are joined to the two terminals of a battery, then the different amounts of current flow through all the individual resistances. That is, different amount of current flows through all the individual resistances, which depends on the value of resistance. This is the circuit diagram from which we are going to calculate the combination resultant resistance of the parallel combination of resistors. Now suppose the total current, okay, flowing through the circuit is I. Then the current passing through R1 will be I1, through R2 will be I2, and through R3 will be I3. And the total current in the circuit will be equal to, that is, I is equal to I1 plus I2 plus I3. Suppose the resultant resistance of parallel combination is R. Okay. Then by applying Ohm's law to the circuit, we get I is equal to V upon R. This is the Ohm's law. Since the potential difference V across the resistance R1, R2 and R3 in parallel is same. So by applying Ohm's law to each resistance separately, we get I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V upon R3. Okay. Now putting the values of I1, I2 and I3 in the equation 1. What was the equation 1? I is equal to I1 plus I2 plus I3. Okay. You can see we are substituting the values of I1, I2 and I3 in this equation number 1. So this is I is equal to V upon R, I1 V upon R1, I2 V upon R2 plus V upon R3. Or we can write it as V into I upon R is equal to, we have taken V common, in the bracket it is I upon 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now cancelling V from both sides, we get 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So in this way, we can calculate the resultant resistance for any number of resistances connected in parallel, and also by applying, if there we have taken examples of 3 resistances in series and parallel, you can calculate the formula for any number of resistances connected in series or parallel. So thanks for watching. That's all for this class. Before ending, just subscribe my channel and press the bell icon so that whenever a new video is uploaded, you will get notifications and you never miss a class from me. Have a nice day. God bless you all.